You've been dealing with real numbers. Today I'm going to introduce you to complex numbers or imaginary numbers. The very first thing you need to know what is, back when you were taught square roots, you were told you can't take the square root of a negative number. Well, it turns out you can. It was just above the math that you were learning. So the square root of negative 1 is going to be what we're going to call I, the imaginary I for square root of negative 1. And that's the basic one you need to remember. So anytime you have a square root of a negative number, you will take the I out and take the square root of the number. Okay? So basically, if I pull the I out, then I'm left with square root of 4. And what is the square root of 4? Okay. So this in the end is going to be 2I. And we do put the I second. So try number 2 and number 3. Alright, so number 2, we're going to have the square root of negative 196. So I know I'm going to have an I because of the negative under the radical. And the square root of 96, you should get 14I. And then what is the square root of 25? That should be 5, but I've got a negative under the radical, so I should have 5I. Number 14 is a little bit different. You're going to have square root of negative 13, square root of negative 13. I know I'm going to have an I to come out, and the square root of 13 has to stay in. And then the second one, I'm going to have an I come out, and square root of 13 stays in. Now, I have an I times I, gives me I squared. And now square root of 13 times square root of 13. Anytime you have a radical that has the same thing underneath it, so two pieces under one radical, or even in two different radicals, it just equals that number, okay? So that equals 13. So I always like to say square root of elephant times square root of elephant equals elephant. Don't ever question it. Just do it. Don't even do 13 times 13. Do square root of 13 times square root of 13 equals 13. And then we need to come up here and discover what I squared is. Turns out that I squared is equal to negative 1. So I always like to say that I squared changes the sign. So I squared is negative 1, and negative 1 times 13 equals negative 13. So the answer to example 4 is just negative 13. Okay, so number 5, let's do that. What is 6 times 3 times negative 5? It's going to be negative 90. And then I times I times I is I to the third power. And I'm going to come up here, and to make an I to the third, that's going to be one I and two I's, so it's going to be negative I. Okay? So basically, you can either do 3 of these, or one of these and one of these, and makes negative I. And you'll memorize these in just a little bit. So if I know that this equals negative I, and that's negative 90 times negative I, that's going to equal positive 90I in the end for my answer to number 5. Okay, number 6, you got 4I times 8I. So 4 times 8 is 32. I times I is I squared. And what do we say I squared does? Changes the sign, makes it negative 1 here. So 32 times negative 1 is negative 32. And that's your final answer on example 6. Okay. Number 7, we've got the way we write an imaginary number is we have a real part and an imaginary part. Usually it's a plus or minus bi. In this case, my real part's 3 and negative 10, and my imaginary parts are negative 4i and negative 7i. We're going to add, so it's just like adding like terms. So I get 3 plus negative 10, and that equals negative 7, and I get negative 4i plus negative 7i gives me negative 11i. Okay. Number 8, I'm doing subtraction, so be sure that you obey the operation each time, or you can distribute it. If you distribute it, then this becomes 1 plus 5i minus 8 plus 3i. Now I can combine like terms. What is 1 minus 8? Negative 7, and then 5i plus 3i gives me 8i. Now if I'd use subtraction, I would say 1 minus 8, negative 7, 5 minus negative 3 makes positive 8. These can be done in your calculator, and I'll show you that in just a second. Okay, 9 and 10. These require you to FOIL. And we've not really talked about FOIL that much. But the easiest way for me to teach someone who cannot FOIL is to do this with cover-up. So what I do is I take a 2 and I multiply it by both. What is 2 times 4 and what is 2 times negative 6i? So that's going to be 8 minus 12i. And that's my F and my O. To get my I and my L, I'm going to cover up the 2. Make sure I don't cover up the sign because I want to use that sign. And I've got 9i times 4 and 9i times negative 6i. And 9 times 4 is 36i, so plus 36i. And 9i times negative 6i is going to be negative 54i squared. Now those are my 4 terms from FOIL, but I'm not finished. The first thing I want to notice is that I've got an I squared. So like I said, what I like to do is know that I squared is this number, negative 1, that's going to change the sign of the negative 54 and make it plus 54. And there is no more I. So I have an 8 minus 12i plus 36i, and then of course that one changed to plus 54. So I go ahead and combine like terms. So I've got 8 plus 54 makes 62. Again, putting my real part first, and negative 12 plus 36 gives me plus 24i. Combining those parts, and that's my final answer to number 9. Go ahead and attempt number 10 and come back to the video and check it. Number 10. Again, we're going to FOIL. So I'm going to distribute the 1. 1 times 3 is 3. 1 times minus 7i is minus 7i. I'm going to distribute a negative 6i times 3. It's going to be negative 18i. Negative 6i times negative 7i is going to be plus 42i squared. Again, don't forget that you have I squared, changes that to a minus 42. So just writing down the first part, making this a minus 42. So the real part is going to be 3 minus 42, and 3 minus 42 is negative 39. Negative 7i and negative 18i is going to be negative 25i. Again, combining like terms, we don't change it. Only multiplying I times I gives you I squared. So subtracting 7i and 18i or combining like terms does not give me an I squared. It just gives me more i's. And that's your final answer. So really quickly, let's grab a graphing calculator, and I'll show you where I is. If you look, it's going to be the shift key of your decimal. So to type in like number, you cannot do number 1 in your calculator. It will not give you an imaginary answer as a result. What you can do is your operations with I. So number 5, you could say 6i 3i times negative 5i, and it will give you 90i as your answer. Again, we're just checking. If you were to do number 7, you would do 3 minus 4i plus, make sure you put the right operation, and I don't know, I always have kids ask, how do you know what to do? Because it's sitting right there, it's a plus sign. Negative 10 minus 7i, and you get negative 7 minus 11i, and that's what we got. Alright, and then number 8, you would do 1 plus 5i minus parentheses 8 minus 3i, and you get negative 7 plus 8i. Then number 9, parentheses 2 plus 9i, close parentheses because this is a multiplication, 4 minus 6i, and it gives you 62 plus 24i. And then my last one to check, 1 minus 6i, parentheses 3 minus 7i, and you get negative 39 minus 25i. Good. Okay, let's look at this I chart. Now, first of all, I to the 1 we know equals square root of negative 1, but we'll just say I equals I in each of these cases. And then I squared equals negative 1, I cubed equals negative I, and I to the 4th would be like multiplying negative 1 times negative 1, so it's going to equal a positive 1. If I were to ask you what I to the 5th equals, you could do that. And your calculator will do these up to a certain point, and then it starts giving you a weird looking answer. But if we did I to the 5th, it would equal I to the 4th times I, which I to the 4th is 1, and then I is I, so it's just going to equal I. And if I were to tell you to do I to the 6th, it's going to equal negative 1. And I to the 7th is going to equal negative I, and I to the 8th is going to equal 1. So it cycles every 4 times. So there's only 4 possible answers to I to any power. It's your choice how to do it, but I'm going to show you the best way I've found, and that's to make your I chart. Now, you'll always start out with I equals I squared equals negative 1, I cubed equals negative I, and I to the 4th equals 1. So here's what I choose to do. So let's just say we wanted to know what I to the 13th is. What you're going to do, again, it cycles every 4 times. You're going to take the exponent, which is 13, and every 4 times it's going to cycle. And we want to know where it's going to land in the cycle. So here's what I do. If you'll take and use the exponent. In this case, the exponent is 1, and 1 divided by 4 gives you what as a decimal? 0.25. And then the next one is 2 divided by 4, and that as a decimal is 0.5. And then I to the 3rd is 3 divided by 4, and that's going to give you 0.75. And then the last one is 4 divided by 4, and that gives you a number 0.0, right? 1.0. I'm not worried about what the whole number winds up being. I'm only looking at each of the decimal endings, okay? So 1.0, it's a whole number. I'm only looking at the decimal ending. So if I were to take 13 divided by 4, here I'll show you how to do that. Just in your calculator, take the exponent, divide by 4, and tell me what the decimal is. Again, I do not care what the whole number is, just the decimal. So we all agree that that corresponds to the 0.25 category. And then I come over to my I chart and I say which one ends in 0.25. Oh, that's the 1/4. So that means that I to the 13th equals I. I to the 13th equals I. Now come over here Let's look at example 11. So I want to take 24 and divide by 4, and I get 6.0. Again, not concerned with the whole number, just the ending decimal, the remainder. The remainder tells me which one it belongs to, and because the remainder is 0, I know that it belongs to an I to the 4th, which equals 1. So I to the 24th equals 1. Now take 57, divide by 4, 57 divided by 4, and I get 14.25. So it corresponds with the 0.25. So I to the 57 equals I. Again, the only possibilities I have for any of these to an exponent are I, -1, -I, or 1. And the decimal is what tells me which one it corresponds to. Okay, for number 13, we're going to rationalize the denominator. We're not allowed to have a square root on the bottom. And you say, but Miss Bradley, we don't have a square root. And I would say, yes, we do, because remember that I is the square root of -1. So since we cannot have a radical on the bottom, then we have to do what's called rationalizing the denominator. And to do that, we use what's called the conjugate. Okay, so go ahead and use the conjugate. And in this case, the conjugate is what's going to take care of getting rid of the radical. And we learned what the difference of squares was, and that's what's going to help me. So I'm going to make it a partner that's going to be a 2 minus 5i. The conjugate of 2 plus 5i is 2 minus 5i. And all we do is we change the middle sign. If this were a -2, we would not change that. We would only change the middle sign to make it 2 minus 5i. But we can't just multiply by 2 minus 5i on bottom. The only thing we can multiply by and not change the value of it is 1. So I'm going to create this special kind of 1, and that's called my conjugate. Okay? So my conjugate is 2 minus 5i over 2 minus 5i. Now all I have to do is do distributive property on top. So I'm going to distribute the 3i. That's going to give me 6i minus 15i squared over, now this is going to require foiling, 4 minus 10i plus 10i, that zeroes out by design, and then minus 25i squared. Now again, this I squared is something that hangs around and just changes our sign. So I'm going to say I squared is -1. So that's just going to make that a plus. And that's just going to make that a plus. So again, the I squared is gone now that I changed the sign. And 25 plus 4 is 29. So I got a 29 on bottom. The top becomes 15 plus 6i, because I want to write it in real part, imaginary part. And that's how I'm okay with you leaving your answer. Sometimes you'll see this split, though, where you'll see the final answer is 15 over 29 plus 6 over 29i. And I think that's how our book leaves it. So I want to make sure you understand that these are the same things. Okay, so let's look at number 14. Number 14 is a little bit different in that we don't have a binomial. There's not a plus or minus sign on the bottom here. So the conjugate of I on the bottom is just I. So again, we're going to multiply by our conjugate, which is 1, I over I, and that just means I got to distribute. So I get 6i plus I squared over 3i squared. And what do we say I squared did? Just makes that a -1. And then I squared makes that a -3. So you're going to have a -1 plus 6i over -3. And here's one of those where if you split it, you would have a -1 over a -3 plus 6i over negative 3. So we would take the negatives away, make it a positive 1/3, and a 6 divided by a negative 3 is going to make it a minus 2i. So that's how you're going to see it. And then our last one, number 15. Seven over 3 plus 2i. Again, what's my conjugate? Just take the binomial there and just change the middle sign. And distribute on top. So I'll have 21 minus 14i over, this again is a FOIL, so it's 9 minus 6i plus 6i minus 4i squared, because the O and the I cancel out. So the top is fine, 21 minus 14i. The bottom, though, the I squared, changes that to a plus 4. And 9 plus 4 is 13. So that's going to be a 21 over 13 minus 14i over 13. Or 14 over 13i. It's another way to write it. So there you go. Your last set of 3, we're solving using our square root. These are your easiest of the section, I believe. And you would just do this. So you've got 3x squared plus 3 equals 0. So what we want to do is we want to move this 3 over, throw it over, or subtract 3, either way. I get 3x squared equals negative 3. And I divide by 3 to get x by itself. So I get x squared equals negative 1. Now, how would I get x by itself if I have x squared? To get x by itself, like we were doing over here, instead of plus 3, we minus 3. So we undid something. How do I undo a square? And if you said square root, you were right. So we're going to take the square root of both sides. Now, when you are the one who takes the square root, you must remember to put this symbol, plus or minus. That's going to squeeze in front of your answer. And the square root of x squared is x, but there are 2 answers. That's why we put a plus minus. This is a mathematical symbol called the plus or minus sign. And it, again, gives me 2 answers, plus whatever and minus whatever. So if you are the one who takes the square root, you must include a plus or minus sign. And what is the square root of negative 1? Think real hard for me. We learned it at the very beginning of our lesson. The square root of negative 1 is I. So the answer to number 16 is x equals plus or minus I. Let's look at number 17. It works exactly the same way, same steps. What was the very first step that we did for number 17? We subtracted 3. In this case, what am I going to do? Okay, I'm going to subtract 128. So I get 8x squared equals negative 128. Now, what did I do for my next step? Here, what was my second step? My second step was to divide by 8. So I get x squared equals negative 16. And my last step, to get x by itself, I want to take the square root. And because I'm the one who took the square root, I must include a plus or minus sign. And the square root of x squared is x. The square root of negative 16 is 4i. So the answer to number 17 is x equals plus or minus 4i. All right, pause the video and do number 18. Okay, we're going to subtract 54. You get negative 54. You get x squared equals take the square root of both sides. So you get x equals plus or minus 3i.